Okay, today we're going to begin our discussion on solving quadratic equations. And the first way that we're going to solve quadratic equations is by factoring. This is one of the quickest ways to solve quadratics, as long as they are factorable. If a quadratic is not factorable, then you can't solve it by factoring. So all the ones we're going to do today, unless we say that it's prime, will be able to be solved by factoring. So, how do I solve quadratic equations by factoring? Okay? So how are we going to do it? Well, first of all, we're going to move all the terms to one side of the equation and set the equation equal to 0. So 0 is going to be on one side, and all the other terms are going to be on the other side. Generally, we like to put our 0 on the right side of the equation. Next, we're going to factor. Next, we're going to set each factor equal to 0 and solve for each x value. I'll show you a quicker way than that. And then number 4, we're going to write our answer as a solution set, where you put braces around your two solutions, because if it's a quadratic equation, it's going to have two solutions. Now, those two solutions might repeat. It's called a double root. I'm not going to be real picky about you putting your solutions inside the braces. Okay? It is the formal way to do it, but I'm not going to be real particular about that. All right, let's start with number 1. Now, in number 1, this thing is already set equal to 0. As a matter of fact, all of these are set equal to 0 on this page. So we're not going to have to move anything on this page. So what we need to immediately be thinking about is, how do I factor? So I look at this and I see that there are not 3 terms. This is not a trinomial. So if it's not a trinomial, you're not going to have the 2 sets of parentheses necessarily, unless it's a difference of 2 squares. But what we always look for first is a what? Always check for GCF. Very good. Always check for the GCF first. So, this does have a GCF. What is it? X. Somebody said it. So I'm going to factor out an x, and that leaves x plus 9 equal to 0. Now, I can't do anything else. Now I'm ready to figure out what my solutions are. Now, I'm going to show you a process that we're not going to have to do every time, but that I'm going to do it this time because I want you to see what's happening here. When we solve quadratic equations, we have to basically set each factor equal to 0 and then solve for that value, because if this left side is equal to 0, and this is a product, the only way I can get 0 on the right side is if the first factor is 0, or the second factor is 0, or they're both 0. That's how we would get 0 over here. So what we do is we set each of these factors equal to 0. So I would say x equals 0. Well, there's nothing else to do right there, is there? And then on the other part, the other factor, I would say x plus 9 equals 0. And then solve. Minus 9, x equals negative 9. So my two solutions are 0 and negative 9. In the form of a solution set, it would be brace 0, comma, negative 9, brace. That's my answer. Now, we are not going to do this each time. We are not going to set each factor equal to 0 separately, because we don't need to. I'm going to show you a shortcut. Alright. I'm going to skip down to number 5 because I want to show you the type of shortcut that I'm talking about. We are going to come back and do these other ones, but in number 5 you'll see what I'm talking about. Now, again, all of the terms are on the same side, with 0 on the right side. There is no GCF here, and it is a trinomial, so I can go ahead and break it into 2 sets of parentheses. Don't forget to write equals 0. Now we have x and x we should have minus and minus, and the factors of 21 to add up to 10 are 3 and 7, or 7 and 3, it doesn't matter which way you do it. Now, here's the thing. I don't need to set x minus 3 equal to 0 and x minus 7 equal to 0 to figure out what x is. What is going to make this expression equal to 0? What x value? What would I have to plug in for x to make it equal to this thing equal to 0?
Would it be 10 or would it be
Plus 3?
Plus 3, positive 3. So, the solutions are 3 and 7. I want you to notice, the opposite of negative 3 is positive 3. That's what makes 0. When you add two opposites, you get 0. The opposite of negative 7 is 7. What if these were positive?
That would be negative.
Then you would have negative solutions because you're looking for the opposite. You're looking for what makes that factor equal to 0. These are your solutions, roots. If this was a function, it would be your zeros of the function or your x-intercepts. Okay? These are the values that if I graph this graph would cross at 3 and 7 on the x-axis. That's what this means. Okay, so whatever is inside parentheses, you're going to take the opposite of it to get your solution. So you say, well, wait a second. What if there's a number in front of x? Let's do one like that now. So let's go down to number 7, because this is going to have one where there's a number in front of x. So here we go. 3 is not a GCF. So we don't factor the GCF out because there's not one. So two sets of parentheses equal to 0. Now we're going to do 3x and x,
30,
plus and minus. And what are the factors of 30 that are closest together?
10 and 3, 5 and 6.
5 and 6. So let's try 5 and 6. It might not work, but let's try it. 5 and 6. Alright, 3x times negative 6 is negative 18x, and 5 times x is 5x. Together that's negative 13x. That works. So we got it right on the first try. Okay, so here's the issue that some students have. They say, wait a second. You just said you're just going to take the opposite of what's in the parentheses, and that's your solution. But look, there's a 3 in front. So what if I did 3x plus 5 equals 0? See what we would get. Minus 5, 3x equals negative 5, divide by 3, x equals negative 5/3. Now, is there a way that we can determine that we could have figured out that the answer was negative 5/3 without doing all this work? Absolutely.
How?
Look at what we have here. If I plug in a negative 5/3 for x, the 3's would cancel, the negative 5 would be left, and negative 5 plus 5 is 0. So how would I get the negative 5/3? Very simple. Take the opposite sign, take the second number over the first number. That's it. So if there's ever a number in front of x, you're going to take the opposite sign, second number over first number, and that's your solution.
Will that always work?
It will work every time. So negative 5/3, comma, what? What's the other root? 6. So what that means is, just for a little practice sake, what if we had 4x plus 7 in our parentheses?
Negative 7 over 4.
Yep. What if we had a 7x minus 3?
Negative 3 over 7. Or
Positive 3 over 7. Okay? Y'all get the drift? Second number over first number with opposite sign. It works every time. Well, it shouldn't be one that can be simplified. You should not have any common factors inside parentheses. You shouldn't. Alright, so if you didn't factor out the GCF, you could have, two numbers that have a common factor. If that were the case, you would reduce it for sure. Okay? Alright, so let's go back up to number 2, where we only have 2 terms, and we do have a GCF.
You can figure out about 2 if you can do it.
2x, and that leaves 2x minus 4. Now, so I didn't factor out the GCF, did I? What did you say? It should be 4, 1, 2. 4x times 1x, or just x, minus 2. Now, if we ever have an x outside parentheses, I'm going to make that neater.
I can't see that.
4x times x minus 2 equals 0. Alright, anytime you have an x outside parentheses, then the solution is just going to be 0. Because what is the only thing that makes the expression 4x equal to 0? X would have to be 0. Because 4 times 0 is 0. That's the only thing you can get to get 0. The only thing you can plug in to get 0. So my solution set is 0, 2. Alright, let's look at number 3. Number 3 is the difference of 2 squares, so it's super fast. X plus 2, x minus 2. So what's my solution set? Negative 2, 2. Alright, number 4 is also a difference of 2 squares. Okay, so we're going to have 3x plus 5, 3x minus 5. So here we have
5 over 3, and the other one is 5. Negative, positive.
okay, so negative 5 over 3 and positive 5 over 3. Because look, this is a 3.
There's a negative sign.
Oh, I see that.
Yeah. Alright, very good. Okay, look at number 6. Number 6 is a trinomial, but there is a GCF, and it is 2. That leaves x squared minus x minus 12 equal to 0. Bring down your 2. Factor the trinomial, x and x. What are my signs going to be?
Negative and positive.
Negative and positive? Yeah, because I got to have opposite signs, right, to get a negative when I multiply. All right, and then the factors of 12 that are 1 unit apart. 4 and 3. So we need to have a negative 4 and a positive 3. So my solution set would be the opposite of negative 4, which is, and the opposite of positive 3, which is, that's it. Okay? Now, there's a 2 outside that parentheses. Does that have anything to do with our solution? Not at all. Because there's no x with that 2. It's just a 2. It's not part of the solution set. Okay, last one on this page. 3x and 2x equals 0. And then plus minus, and then 2 and 2, and see if this works. So we're going to have a negative 6x plus 4x, and that's negative 2x, and that does not work. So I don't think the 2's are going to work. Let's try 4 and 1.
What are we trying to get? We're trying to get 5.
We're trying to get, 5 in the middle. So let's try 4 and 1. So we got a negative 3x and a positive 8x, and that works. So this is the correct answer. So my solution set, Bradley, what will the first solution be?
4 over 3. I'm a negative 4.
Negative 4 over 3.
And be positive 1 over 2.
There you go. That's it. Okay, very good. Alright, I'm going to stop the video and we're going to do some practice. Alright, so in number 9, notice that we do not have the variables or the terms in general on the same side of the equation. So we've got to move everything to the same side. So I'm going to subtract this 5x over to the left side. 2x squared minus 5x equals 0. Okay, so now it does have 0 on the right side. What? Okay. Part of it. All right, so I'm gonna just let you. I'm gonna hold that there for just a minute. Let's go to number 10. Okay, we don't want this x squared on the right side, so we're going to subtract x squared from each side. That's going to give us 7x squared minus 1x squared is 6x squared plus 8x equals 0. I'm going to leave it there for a minute. Okay, look at number 11. Again, we don't want the x squared minus 1 on the right side, we want it on the left side. So let's subtract the x squared from both sides, and let's add the 1 to both sides. We want to just move the stuff on the right side over to the left side. So this will be x squared, because 2 minus 1 is 1, minus 49 equals 0. Okay, let's do the same thing in number 12. Let's subtract 81 from both sides, and let's add x squared to both sides. So we're left with 0 on the right, and then 4x squared minus 81 on the left. Be careful to put your terms together appropriately. Alright, look at number 13. We don't want the 80 on the right. We're going to move it over to the left. Subtract 80 from each side. So x squared plus 2x minus 80 equals 0. Alright, number 14. Again, we don't want the x plus 4. We're going to subtract x from each side. Minus x from each side. Make sure you put it with the correct term, and then minus 4 from each side. 0 on the right. X squared plus 10x plus 25 on the left. This stuff's not a big deal as long as you're willing to be disciplined and move it over. Alright, 15. Subtract x squared from both sides. Make sure you line them up. Add x to both sides. 0 on the right. X squared minus 8x minus 65 on the left.
So, you're just moving all this stuff.
Just moving it over. Okay, number 16. Minus 2 plus 3x plus 3x. 0 on the right. 4x squared plus 44x plus 96 equals 0. Alright, number 17. Minus x minus 21 minus 21. So 2x squared minus x minus 21 equals 0. Notice there's nothing to combine the negative x and the negative 21 with, so we just write an expression. And then 18 minus x from both sides, and add 9 to both sides. So we end up with 4x squared minus 12x plus 9. Alright, now we've got everything fixed to where we can start factoring. So I want you to go ahead and start factoring. Do numbers 9 through 12. 9 through 12.